Professor Mihaela Albu, UPB Bucharest, Romania.
Also, thank you for being here. Thank you for Professor Dashama for enabling my presence here. Well, the title of this intervention for me is very fancy, and it's related to what technologies will impact the energy system and will shape our world for the next 10 years. So don't imagine that after my talk you'll go and invest in what I'm speaking about. My aim is to give some guidelines from my perspective in what to invest the work of young graduates and postgraduates if they want to be in line with what is happening in power system in the next 10 years. And as Mr. Bhattacharya already said, I think it's, no, it's okay. One key word is sustainability, and thank you for the presentation before. What I think is more, from my perspective, the translation of this sustainability in energy world is we have to solve the issue of energy in multiple energy vectors. So we will not look separately to the electricity, although this is my favorite subject, yeah, as I said, a power engineer, who, by the way, grew up in the largest coal-fired power plant in Romania 20 years ago. Not only electricity, but how to optimize the use and the generation of other energy vectors, those thermal or, of course, cold and heat, be those hydrogen. So this being said, the problem that has to be solved somehow immediately is to combine and to agree with the models used for so many years in each separate field. And these models evolve. And just to take an example, doesn't matter if we will still keep large power plants with generators with large inertia. The fact that we use electricity with basically zero inertia, which mechanical inertia, because just to think about everything we use today is phased or interfaced with the power converters. This is zero inertia. And then we add the generation, some generation, which is renewables based, which has also zero inertia because everything is interfaced with power converters. which means that our models, which were based on minutes or even seconds, power profiles and control, they have to revisit it. How to revisit the models? Only by measurements. So only by taking the information from the real systems. So one area that I think that will develop and will change actually in power systems for the next 10 years is how we perform the measurements. And of course, how we further process the measurement values. As I will talk maybe more tomorrow, we base our all knowledge on power systems, not like in physics. We base on averages. We speak on average. It's not enough anymore. We have to go down to below 1 second time resolution, maybe milliseconds, in order to perform a optimal control. Now, if I'm speaking about control, another area very much related is that in many applications, difference between or differentiating between protection and control and monitoring, as we call to use it in the control centers, will be much more difficult to be done. Yeah, will be a kind of mixed, and we see this mixture when together with the invention of the phasor measurement units, which was the first synchronized measurement application for power systems, where this entity, this equipment, actually, they were initially protection systems, and then the standards and everything evolved towards a very good and very useful measurement system. Now, another area, so which I also see as developing very, very much, is DC technology. I know that, well, Edison was defeated with DC many years ago, but now, fortunately or unfortunately, most of the generation, most of the storage, most of the electricity used, doesn't matter if it's computer communication or electric vehicles, is basically DC native. Is not mediated DC, is DC native. We have no measurements for DC, we have no definitions. Now there are standards prepared to be developed in order to understand what does it mean, for instance, 700 volt DC. Okay, it's a wrong explanation. 700 volt at direct voltage. What does it mean? Is for the past 10 milliseconds, is for the past 1 minute, what is the measurement time, what is the reporting time, and so on and so forth. So related to DC, also another emerging technology, which we might say that is there for some years already, it's the vehicle-to-grid. Yeah, let's say vehicle-to-grid technology. So to use the electricity stored in the batteries of electric vehicles to help the network, distribution or network. Well, we see that this technology, although it was announced by the major producers of the electric cars that will be enabled, will be there, is still, if you look on the projects worldwide, there are only a few projects with vehicle-to-grid technology, and this, in my mind, is really prepared to be done for the next in the next decade. And I will close with something more scientifically related. In order to pursue with those achievements, or with this very fast pace of development that is needed in power systems, will be and already started to be used very much the technique of hardware in the loop, power hardware in the loop simulations, so numerical simulations, which enable to direct link real-time, really real-time, with the to be tested device. And one example, as you know, is RTDS, is Opal, is Typhoon. From the last one, just to have an idea, they enable reading the digital inputs every 20, even better, 20 nanoseconds, and also to perform one-step full simulation below 500 nanoseconds. So this is what we need in order to answer to a very, very fast changing power system, at least for the distribution. Let's speak on distribution and low voltage, medium voltage volt, which is dictated by us, the users. Thank you.
Hello. So thank you, Mihaela. Professor Mihaela Albu, she has emphasized on how the power system technology is changing under the multiple energy vectors and focused on the importance of measurement and processing of measured values for models in power system. She has also briefly talked about vehicles to grid technology, which will be very much important when we will have a lot of electric vehicles on road in the coming days.